Welcome. In this class, we are going to discuss the phasors. Phasors simply called as vectors also. So, why we are using phasor? So, phasor means we are converting a alternating quantity into a vector diagram or phasor diagram for easy calculations. So, we all know the instantaneous value in every position of the alternating quantity. This depends upon its sign angle. So we can convert a alternating quantity into a phasor. Suppose consider one waveform, suppose a voltage waveform, maximum voltage at 10 volt, clear. So it starts at 0 degree and it attains its maximum value at 90 degree, and again its 0 comes 180 degree, half cycle completed. Again its opposite, negative value maximum at 270 degree, and again it reaches 360 degree, it becomes again 0. Just one complete cycle. So this value we can convert into a phasor. Now consider just one magnitude with respect to its angle. Its magnitude means its maximum value. Its maximum value means 10. So its maximum value 10 is its magnitude or its radius. So at any point, suppose we are rotating anti-clockwise direction, at any point we can find out its value. For example, now the phasor is laying on x-axis. So we can take it as a 0 value. So we can find out at 0 degree what is the value. So its magnitude is 10. So 10 into its sine function, sine 0. So its value is 0. So at this position value is 0. So whenever, suppose we take it as 30 degree, when the phasor we are drawn in 30 degree angle is 30 degree, that is cancelled. Now we can find out what is the value of at 30 degree. So 30 degree means its magnitude into sine function, sine 30, that is sine 30 is 0.5. 0.5 into 10 means 5 volt. So at 30 degree it is 5 volt. So this is a 5 volt. Suppose the magnitude is reaches 90 degree. So now it is 90 degree. 90 degree. So now we can find its value. So 10 into sine 90. Sine 90 we know the value, that is 1. So 1 into 10 means that is 10. 10 volt. So at 90 degree it is 10 volt. So this equivalent is 10 volt. So every position we can convert with respect to its phasor. Clear? So at what position, what the value we can find out of its sine function. So it is called a sine waveform. So we are converted, now simply we are converted a sine waveform into a phasor. Now at any angle we can find out the value with respect to angle with respect to its x-axis. Clear? And moving with respect to anti-clockwise direction. So next question is why the need of phasor. So phasor needs to calculate the multi-alternating quantities. Suppose we have more than one alternating quantities, we have to convert the alternating quantity into phasors, then only we can calculate it. Or else it is very difficult to calculate in graphical method. So to easy calculation we are making the phasor conversion. So waveforms we are converting into phasor value, and that phase value we are calculating. Addition of two alternating quantities or subtraction of two alternating quantities or division of two alternating quantities, or at any point what is the value of total alternating quantities or difference, potential difference between two alternating quantities, etc. So for easy calculation only we are converted the alternating quantity into phasor. Now just I am reminding the lead and lagging. In the earlier or first or second video I discussed about the leading and lagging of the alternating quantities. Suppose here one more waveform I am drawing here. Suppose our first waveform, suppose it is taken as V1. The second waveform starts at 90 degree and again 270 degree or 180 degree after it reaches 0. Again it is moves on and again reaches 0 after 180 degree. Clear? So this one is called as V2, voltage 2. So its extension. So while looking only, we can understand the second waveform is lagging behind the first one. I am taking the red colored waveform or V1 as a reference because it is started from 0. So comparing to reference waveform, the second waveform V2 started after 90 degree. After 90 degree it started, or you can judge it is started below the x-axis. Whenever any waveforms started below the x-axis with respect to our reference waveform, so that waveform always called as lagging waveform. We discussed earlier. So once again I am reminding. So second one is lagging. How much lagging means? It is 90 degree lagging behind the first one. Clear? Now just remember, the second waveform is lagging with respect to first one is 90 degree. Clear? So we draw on first one. First waveform is here. Already drawn. The waveform or phasor is reaches its 90 degree. So already we drawn 90 degree. So I am taking this position. So at this position, what is a vector or phasor diagram? So at this position, the phasor of first one is 10 at an angle 90 degree with respect to x-axis. Clear? Now, what is a phasor of second waveform? That is a question. The second waveform starts after the 90 degree. So we are taking anti-clockwise direction. So it is lagging by 90 degree. So lagging means behind. Behind 90 degree means it's behind 90 degree. Behind 90 degree means this is the position. This is the position of V2. Clear? This is the position of V2 now. First one, comparing this point, I am taking this point because already I drawn the position of first one. So comparing first one's position, second one is behind the first one by 90 degree. So our vector diagram comes like this, or phasor diagram comes like this. One is V1, second one is V2. Clear? Once we got the V1, V2, etc. Suppose one more waveform I am drawing, so we can convert it to one more phasor. So this one is looks like our phasor. Phasor or in polar form. Clear? Or in polar form. Last video I discussed about complex numbers in their polar form. So any value we located with respect to its magnitude and its angle. So this one V1 we can denote it as V1, its magnitude is 10. V1 at an angle how much? 90 degree. Clear? And V2 also same, 10, maximum value is 10, so 10 units. So V2 is V2 at an angle 0, or simply we can write its magnitude. Its magnitude 10 at an angle 0 degree. The second one, or first one is V1 is 10 units, 10 at an angle 90 degree. Clear? So we got two waveforms in the form of phasor. The phasor is in the form of polar form. So polar form we got. So from the polar form, now we can add or subtract two values or two alternating quantities. Why? Because we got in polar form. Now we can convert this polar form into rectangular form. That rectangle, both are in rectangular form, and we can perform its addition and its subtraction. Clear? Simply we can't do. Suppose it look like, suppose this one is a maximum value, it is 0, but not like this. These are phasors. We can't say directly how much value in difference. What's the value now? Both we are taking. Suppose v1 plus v2. What's the value? We can't say it directly because it is a phasor or vector. With respect to angle, we have to add. With respect to angle, suppose we are adding, we will get one more value with respect to some value. Suppose we have to add same 10 at an angle 90 degree and 10 at an angle 0 degree. We can add. So I will perform here. So V1 in the form of polar form 10 at an angle 90 degree. So I am converting this one into rectangular form. So rectangular form, how to convert means, first part x plus yi. X is r cos theta. Here r and theta is 90. R is 10 units, theta is 90. So first part r cos theta and imaginary part is r sin theta I or j. Clear? So substituting r means 10 cos 90 plus 10 sin 90 into I. So what's the value of cos 90? Cos 90 is 0. Cos 90 is 0. So 0 into 10 means 0. Sin 90 we know sin 90 is 1. 1 into 10 means 10. So it becomes 0 plus 10i. 0 plus 10i is the V1 conversion. Similarly, I am converting V1. Second one I am converting V2 equal to 10 at an angle 0 degree. So converting R, there is no space, so I am directly writing the value. So its real part is 10 cos 0 plus 10 sin 0 I. So we know that cos 0 is 1. So 1 into 10 means it becomes 10. Again in this part sin 0 is 0. So 0 into 10 means 0. So plus 0 I. So V1 and V2 we got in rectangular form. This is rectangular form. This one also rectangular form. Clear? So both value we converted two waveforms or two alternating quantities into phasor. The phasor are in polar form. So that polar form we convert into rectangular form. So we did one comparison. What is the advantage of polar form and what is the advantage of rectangular form? For addition and the subtraction we can use rectangular form, and division and multiplication we can use polar form. So here I want to V1 plus V2. So it is simple calculation with respect to our rectangular form. So I am doing V1 plus V2. V1 plus V2 I am doing. So V1 is 0 plus 10i. Again plus V2 is 10 plus 0i. Clear? So real part addition, real part 0 plus 10, that is real part is 10. Again imaginary part 10i plus 0i, so again 10i. Clear? So this is the answer V1 plus V2 in rectangular form. So also rectangular form. Clear? So now we can convert the rectangular form into again polar form. So we know the equation how to convert the rectangular form into polar form. This is V1 plus V2 in rectangular form. Now how to convert means find the magnitude. Root of R equal to root of real part square plus imaginary part square, and its angle means theta equal to tan inverse imaginary part by real part. So I am doing here. So here magnitude R equal to root of real part is 10, that is 10 square. Again imaginary part is again 10, so imaginary part square. So root of 10 square plus root of plus 10 square is 100 plus 100, that is 200. Root of 200 becomes 14.14. So that is 14.14. So magnitude, or we are doing everything in voltage. So this much voltage. Clear. Now what is the angle? Angle equal to theta equal to tan inverse tan inverse imaginary part is 10, real part is 10. So tan inverse 1 means 45 degrees. So we converted V1 plus V2 rectangular form to polar form. The answer becomes 14.14 at an angle 45. Clear. This is a V1 plus V2 in polar form. Clear. So where we started? We started from two alternating quantities. We convert in phasor. Again the phasor in polar form. Polar form to we convert in rectangular form. Again rectangular form we added. Again we got the output in rectangular form. Again we converted into polar form. So now we got polar form output. Now I am here. The V1 plus V2. What happens in the diagram? So V1 plus V2. We know that parallelogram method. How to find the parallelogram method means we are drawing a parallel lines to one phasor, again parallel line to another phasor. So we can write or we can draw parallel to V2. It is simple because it is lies in the x-axis, and this one also it is simple. It is parallel means it is y-axis. So this parallel like this. So this is a parallelogram method. Now the answer is two phasors adding the parallelogram method. This is a output waveform. V1 plus V2 we added parallelogram method means this is the output. Same we did here. So first V1 we taken in polar form, V2 we taken in polar form. Now we converted into rectangular form and added. Again we find out the total output, or V1 plus V2 is 14.14 for at an angle 45. That is a 45 is an angle and its magnitude is 14.14 volt. This while adding at the position of this position, while adding two vectors we got this output, this much voltage. Clear. This is a phasor addition. How to find two voltage to be added means this is a method. So to calculate very easily we converted the values alternating quantity into phasor. Phasor is look like in polar form, so we did in complex format the addition. So this is advantage of phasor, that means it gives simple calculation, or it is very difficult to add two alternating quantities, because the alternating quantities are depends upon every point its angle. So now we did the calculation with respect to angle only. Clear. So final output is this one. So suppose we are measuring at this position at 90 degrees. Suppose we are measuring using some electronic equipment, then multimeter we will get this value. Clear. Or its RMS value we will get 14.14 divided by root 2. So RMS value we can find out. Clear. We did this one in maximum value, so its RMS value we can find out. Clear. So at an angle 45 degree we got the output. So this one is the phasor explanation. So why phasor means, for easy calculation we are converting waveform to phasor diagram. Phasor diagram already we discussed is in polar form. So when any points we got in polar form we can convert into rectangular form, then we can perform the complex calculation, subtraction or addition in rectangular format. The output came in rectangular form again we converted into polar form. So we drawn the output waveform. This is the addition of V1 plus V2. Similarly, we can add current, two currents, two alternating currents we can add. In DC it is very simple, but in AC the addition of voltage or addition of current it is taking in, or all the calculation is doing in complex format. So for complex format we want to convert the alternating quantity into phasor. So one very important point. So all are should understand what is a phasor, what is the advantage of phasor. So everything we are going to do for easy calculations only. And here one important point is leading and lagging. How to convert the alternating quantity into phasor means we have to know leading and lagging. These 2 points we have to know. If you know exactly what is leading, what is lagging, then only we can draw very easily phasor diagram. So I will give one example, one more example. So this one is our x-axis, y-axis, one voltage waveform, clear. And again after 30 degree, one current waveform. This is a current, this is a voltage. Now easily we can draw the vector diagram. Suppose voltage is started from 0, so we can take it as voltage is our reference. So voltage waveform, voltage is a reference, so this is a V voltage. Now we take it as this one is 30 degree, clear. So now we can understand the current is lagging by 30 degree from voltage, because it is started below the x-axis, clear, and its 0 position also after the voltage after 30 degree started. So it is lagging means this one is now x-axis, lagging means this one is first, lagging means it's behind, so this is a current lagging by 30 degree, clear. So we converted voltage and waveform, voltage and current waveform with respect to phasor. Now phasor, V is a reference, with respect to reference, current is lagging, so lagging phasor by 30 degree. Again one more example, suppose leading, what will happen? Suppose waveform started from above the x-axis, clear. This is now current. Now again this one is 30 degree. Now what will happen? Again our reference is, I am taking current on voltage only our reference, clear. Voltage we taken as reference. So reference is we drawn here. So now how much current is leading? The current is leading by 30 degree. So leading is top side. This is a current. So this is the way we are converting the waveforms into our phasor diagram. Once we got the phasor diagram, we can write its polar form. This 0, clear. Suppose I take this one is a reference, so this is a 0 value, so current is at an angle 30 degree, clear. So how to convert alternating quantities into polar form? Once we got the polar form, now we can perform any calculation with respect to polar form or in rectangular format. One more thing, how to convert all the phasor value into rectangular form. You have to know some points. Suppose this one is a 4 quadrant, clear. This is a first quadrant, it's a x-axis, this is a y-axis, second quadrant, third quadrant, it's a fourth quadrant, clear. So now any value in first quadrant means Actually x-axis means it is a real axis and y-axis means imaginary axis. Clear? So any value in first quadrant means, so this is a value at an angle some degree theta. Clear? So now we are calculating any angle with respect to x-axis only. Just remember, any angle we are calculating x-axis only or with respect to positive real axis only. And again we are measuring positive value anti-clockwise direction only. Anti-clockwise direction. Clear? This is a positive value. Suppose we measured in clockwise direction. Suppose we measured clockwise direction. We have to take it's a negative. Clockwise direction should be negative. Clear? So always remember, whenever with respect to x-axis or positive real axis we are taking the angle, that also positive anti-clockwise direction and negative clockwise direction. Clear? So this one is clockwise direction we measure, so positive theta. Suppose we drawn here one more phasor, we written here. Suppose this one is 60 degree. Clear? 60 degree. So we have one, whenever we are writing the polar form, suppose this one is value is I, its polar form should be I minus 60, because we measured clockwise direction. So clockwise direction we have to include minus. Okay. Anyway, the magnitude of angle is 60, but while writing the polar form we have to write minus 60. Clear? Or one more. Suppose you want to write positive value, you have to measure clockwise direction. Clear? What is the angle now? Clockwise, anti-clockwise direction. From x-axis, the anti-clockwise direction you have to measure. So how much this one? 180, 180 again, 90 again. How much will come means total 360 minus 60 means it becomes 300 degree. Clear? So we can write, instead of minus 60 we can write I at an angle 300 degree. This one also correct, this one also correct. So just remember anti-clockwise we have to write positive, or clockwise we have to write negative. Clear? Every time you have to remember these 2 points. You have to remember these 2 points, because we are measuring with respect to positive real axis, and all the calculators are taken reference is positive real axis. Clear? Suppose we are converting any polar form to rectangular form, again we are converting polar form, etc. We will get some angle. That angle should be reference to x-axis. Clear? Positive x-axis. Suppose anti-clockwise positive, this one way it is negative. So just remember, why I said means, now just remember, suppose any one polar form here with respect to angle theta, we can convert this value into, this one is r at an angle theta, this one we can convert into x plus yi, some value. Clear? We can convert into rectangular form. Here both are positive, x also positive, y also positive. So positive, there is no problem. Clear? There is no problem. So positive, angle also positive. Suppose we know only rectangular format, then we are converting theta equal to tan inverse imaginary part by real part. Here both are positive, so we will get positive angle. So positive angle means just we can write r at an angle theta, positive value. Clear? Suppose some value, we know that this one is again x axis positive, so x, but imaginary part is negative. Now negative comes minus yi. Clear? Now how to convert polar form means r at an angle theta. How to convert theta means theta equal to tan inverse, imaginary part is now minus, so minus y by x. So once here minus comes, the angle becomes minus theta. So you have to write minus here. Clear? R at an angle minus theta. Automatically it will come because minus y we are inserting. So with respect to minus, the theta becomes minus. So we have to write minus theta. But here the problem comes here. So what happens means, suppose some value here, what happens means x axis or real axis is negative minus x and imaginary axis is positive. Clear? Positive I. Because this is a point. This point is denoted as x minus x plus yi. So how to find the angle? How to find the angle means how much x value, this much x value and this much y value. So angle should be, this is the angle. So this is the angle. So while doing the tan inverse, y by minus x, definitely we will get minus theta. Clear? Definitely we will get some, because minus of this minus theta, minus angle will get. Suppose we not inserting minus sign, only magnitudes are we are including, we will get positive. Anyway, no problem. Clear? So but we want angle with respect to our x axis, not negative x axis, positive x axis only we want the angle. Clear? So positive x axis value we want this theta, not this theta. Clear? We want this theta. So what to do to find this one? Suppose doing this calculation, tan inverse y by minus x value will get minus sign. So total we know that 180. Clear? We got minus theta here means 180 plus minus theta means the remaining theta will get. So actual theta means theta equal to 180 plus tan inverse y by. Now third quadrant. In this third quadrant, suppose our phasor is this one. Now here real part also minus and imaginary part also minus. So x minus yi. This is a rectangular format. Clear? So how to find its angle means, so how much real axis value and how much its imaginary value. So this is the angle. Angle will come this one. Clear? So while doing the calculation, the tan inverse minus y by minus x. So here minus x and minus y. So minus should be cancelled. So we will get positive value only. So once we got positive value, the theta also becomes positive theta. Clear? So we got theta here. We just got theta value. Not from the angle from positive x axis. We want this one. We want the angle from positive x axis to the phasor. Clear? So to get that one, so now this one becomes positive means we will get positive angle. So we have to add. So this much angle we know 180 degree. 180 degree comes here. So again plus this much, how much angle we got? The angle. So we have to write 180 plus this is theta. Theta equal to 180 plus tan inverse minus y minus x value. Clear? So here suppose we included only magnitude y by x. Same. In the earlier case only we just should be careful about the sign comes in the denominator. Whenever sign comes here, we have to write positive here. When there is no signs inserted here, we have to write minus it. Clear? So but in the third quadrant nothing will happen. Clear? So positive positive or negative negative cancels. So this angle plus 180 means total angle. This angle plus 180 means total angle we got. This is answer. Here one more thing. Here one more thing also happens. The same angle we can measure from this side also. Clockwise direction also we can measure. So suppose we want the angle from clockwise direction, what should we do? We have to do here minus. Clear? And total minus here. And minus here and total minus, because the clockwise direction we are indicating minus sign. So 180 total from this one, 180 minus this angle means we got the remaining angle, but we have to write minus, or else we have to write the opposite side, the tan inverse minus y by minus x minus 180. This one also correct. Clear? So we will get what the value will get? The theta will get, the angle will get angle minus 180. So we will get the minus itself. Minus 180 means it should be lesser value, it's a larger magnitude. So we are indicating larger magnitude sign. So automatically the theta will get minus sign. Clear? In the calculator this formula is used. Clear? Whenever we are doing the calculation in the third quadrant, the answer should be minus theta from clockwise direction. Clear? We can find out the anti-clockwise direction. The equation I written already. The theta equal to 180 plus tan inverse minus y minus x. Clear? In this case we are getting positive theta with respect to clockwise direction. In this case we are getting minus theta, that is clockwise direction. That's the difference. So clearly understood? This one should be anti-clockwise direction, positive theta. Second one is clockwise direction. So clockwise direction is minus. So minus theta. Clear? So you have to write. Suppose writing the polar form, we can write positive theta or we can write minus theta also. But the theta value is varying. Clear? Theta value should be varying. So remember, clockwise direction positive, anti-clockwise direction negative. Clear? And the last quadrant, fourth quadrant, that is already we discussed. Fourth quadrant is simple, just using the imaginary, negative imaginary value, the value becomes minus theta. So we are just indicating minus theta because it is very nearer to x-axis, positive x-axis. So we can measure this angle only. So minus should be indicated. Here we can measure anti-clockwise or clockwise. Anyway, this is a anti-clockwise direction. Clear? This is a clockwise direction. So remember these two conversion. Clear? These two conversion, the calculators etc. using this one. So you can use this one also. Anyway, this one also you can use. Any answer. Both answers are correct. Clear? So this one is a just remember all the points. Whenever we are doing the calculation, phasor calculation, just remember first quadrant should be positive, second quadrant will get negative. Negative sign means we have to add it. We have only magnitude means minus it. Clear? Again, third quadrant, both we can anti-clockwise or clockwise, we can find out the degree. And the last quadrant, just indicating, just minus sign means minus, just indicate it. Clear? So these are phasor calculation, some tips. So we will do some problems on it. While doing the problems, the answer angle should be based on these values. You have to remember every time these values. Clear? What should become? What the angle should become? Suppose the angle after 90 degree. Clear? What is the answer? What is the answer? Third quadrant. What is the answer in fourth quadrant? Just looking the value of rectangular coordinate, we should know what is the angle. Here also, what is the angle? We should know. Minus real part, positive imaginary part. Here also, minus minus. What is the answer? Here also, positive and minus. Clear? So what is the answer? We should know what angle should come here, what angle comes here, what angle comes here, what angle comes here. Clear? Here always comes less than 90 degree, positive degree. Here comes less than 180 degree, positive. Here comes both positive more than 180 degree or negative less than 180 degree comes in third quadrant. Negative means your answer should be positive more than 180 degree or negative less than 180 degree should be the answer. Here in the fourth quadrant, positive negative comes, your answer should be negative less than 90 degrees the angle. This should be, you have to remember these points. Clear? Thank you.